Welcome back to the video of my channel, Math_exe. So here is a problem solving question, and it says that we need to find all solutions for primes p and q such that p to the q plus p is also prime. Now the key to this is to look for cases. So that is what I'm going to do today. So just observe case 1, and let's see, we can have p to be even and q to be odd, and let's see what we'll have. And since p and q are primes, and more specifically p is an even prime, we know that p must be equal to 2, since 2 is the only even prime that exists. Alright, so let's see what we have. So the expression will reduces to 2 to the q plus 2. And notice that q is greater than or equal to 2 since it is a prime, and this expression is even, and you can see that because you can factor out a 2 from this expression. And furthermore, we're given that this expression is greater than strictly greater than 2, since you can just pretty much see that easily, since if you want q to be odd, and the smallest possible q value will be 3, and then from there you can easily observe that this expression is always greater than 2. And since this is greater than 2, and this is even, and this is composite, so this expression will be composite. I'll just write that here, meaning it is the opposite of prime numbers. So in this case, we'll have no solutions. Alright, so let's see for case 2. For case 2, we're just going to suppose p and q are both even, and furthermore we're given that p and q are primes. That means p and q are both equal to 2. So let's see what we have. So we have 2 to the 2 plus 2, which is equal to 6, which is obviously not a prime. So also not solutions for case number 2. How about case number 3, where p is odd and q is even, or in other words, since q is a prime, then q is equal to 2. So we'll have p to the 2, or p squared plus p. Right, so let's see, since p is odd, we have a odd number squared, and a odd number squared is just an odd number, and an odd number plus another odd number will be even. And you can just see or plug in some values, or plug in some very small values like 2 or 3 for p, and you'll notice that this expression is always greater than 2. So hence this expression will be composite as well. So in this case, no solutions. And finally, for case 4, we need to check when both of these are odd. So I'll just rewrite the expression here, and just observe carefully. So notice that p and q are odd. Now an odd number raised to a odd power will be odd. Well, actually, an odd number raised to any integer, an odd number raised to any positive integer power will always be odd. And since we know q is a prime, and prime numbers are a part of an integers, the first term will be odd. And furthermore, we're also given that P is also odd, and then we have odd plus odd, which is even. And if you plug in the minimum values of P and Q such that P and Q are odd primes, which will be 3, and you notice that this is greater than 2, and therefore this expression will always be composite. And that in fact is the last case that we need to check, and none of these will give us solutions, so there are no solutions for primes P and Q. Alright, so that's it for this short video, and I hope you guys enjoyed this. Please subscribe for more, and I'll see you guys in the next one. Goodbye.